60 sides. Or no?
No,
Because some of the overlap.
yeah, the overlap. Yeah.
Why are you so
There's no. You wouldn't call them sides. You call them edges. It would only have 12 faces, but then the edges are all those segments between them. There's quite a bit.
Okay. Okay, sorry. So, it's a long
25.
decade.
Yeah, something like that. Yeah.
Oh, me too.
All right.
How many edges are on the
Yeah, we're just doing it. It's super easy today, which is actually crazy. Like we're actually back to a little bit easier stuff. Kind of nice. All right. Hey, we get back to a little bit easier stuff today. Now, you still have homework that's due on Friday.
Thank you, Jesus.
You have a worksheet that's due this coming Friday. That worksheet in particular is based on graphing rational functions. So you got to know where the curves are going, you got to know where the asymptotes are going, and all that. Now, if you'd like, I'll do one example of one on the board today. If you want to see another example how to do certain things, especially one with like a 0 for a horizontal, we can do one of those. I'll just kind of pick a basic problem. But my goal today is not to do that. It's to go through the new stuff and intro the new stuff today. Just a light introduction, and then give you time to work on the worksheet. Got it?
That is not about what you said.
All right, so here we go.
I was thinking about
Here we go. All right.
I don't like girls because girls like guys and that's good.
I have that on my phone. I have a list.
Hey. Okay.
I'll
All
let
right,
you read it.
first, we need to talk about limits today. We're just going to talk about the real basic things about a limit. We're going to talk about the basic definition. And I'll just put it in crude terms. I'll give you the formal one tomorrow. And then we'll talk about a few examples of what I mean by a limit today. And so that's what I want to discuss today. In these examples, we will talk about a few basic properties. So I'm going to talk about a few properties which are called the basic operations of these. So add, subtract, multiply. Okay, that's what we're going to talk about today. My goal is to select a few problems, get done super early, give you time to work, because I know you need it. This worksheet is not easy. It takes time. You might have questions on it already. I understand that. Okay, I would strongly recommend you start soon, because we're going to start reviewing for the test probably as early as Thursday for next week, because we're on the last section.
Don't tell me we're taking a test on Monday.
No, Tuesday.
Next Tuesday.
That's so Monday.
So in 1 week.
It's just Monday.
It's better than Monday.
Well, last week you said we'd have a test this week.
No.
Yeah, and I push it back because we still got one section to go. We have homework due at the end of the week, and I still want to do a
Well, I
2-day
just
review.
spaced
This
it
is
out
the
last
word.
time.
That's okay. Do you think BI section?
Last section.
Next week's
Okay.
I like
All right. Last section of this stuff. This is called limits. Now, let's just talk about the real basic definition of what a limit is. A limit is where you approximate what the graph is doing at a certain moment. That is like the super crude way of examining it. I'll give you an example. So just kind of pay attention here. So imagine you had. I'll go with the idea that you brought up here earlier, there, Trav. If you had a polygon. Okay, a polygon has certain straight walls, right? Not 3-dimensional, 2-dimensional, flat, right? So you're drawing on a little piece of paper. So if I drew like a triangle, right? That's a polygon. Straight edges, no curves. And then I draw a quad, right? And then I draw a pentagon, where it has 5 walls. What would happen if I kept adding walls and got up to, let's say, 100 gone? That was a limit. What you just did there, mental. Saying that it would look like a circle. I didn't tell you it would look like one. You kind of had this idea where it was going and what it was starting to kind of blend into.
I thought it'd just be wasting time.
No, but that's what a limit is, right? A limit is this idea of like you're trying to predict the outcome before it comes about, and you're trying to make an educated guess just on basic parameters. Now, it doesn't just have to be what would happen 1,000 down the road. It could be the idea where you're looking at one specific idea on the problem, and you're just looking at like where the limit would be on one particular notation. So here's what I want you to do. On your paper, you don't need to have graphs. I want you to draw this. So let's do something like this.
So I don't need to.
You don't need to have graph paper. Just put this in your notes somewhere. And again, it doesn't have to be super exact. It just has to be close. Okay. All right. It just has to be close to what I have here on the board. This is giving me my examples that we'll go through today that fill my idea of what a
You just
limit
made
is.
that up, right?
Yeah,
Did you
made it up.
put that 1 point just to chill up there?
Yes. There is that dot is on purpose.
Wouldn't that make it not a function?
Okay.
That's not
Okay,
right.
Well, there's an open hole. So it would pass the vertical line test.
When he said open.
I hate
hole.
that example. That's cool.
All right, now it's not continuous. There is breaks in the
Oh,
graph.
you weren't in that class.
Okay.
Morgan's name is Sydney.
She looks like Sydney.
Hey, let's focus.
Sydney's on
Now.
the chart.
Okay. All right. Now on this graph, if we look at a limit, let's say I want to look at a limit. I want to look at a limit as your function of x, as x approaches the number 3.
3 what?
As you approach 3 on the x-axis.
Wait, L-I-M.
On the x-axis.
Limit. So what this stands for, this word here is the limit. So they just abbreviate LIN, limit.
Yeah.
As x approaches 3. So that's how it's written, that's how it's set, is as x approaches the number 3. Approaches 3. And what we're trying to do is figure out what your function of this graph is going towards. So as I go to number 3, here's number 3 on the x-axis, right? Look at your graph. What are we slowly approaching as we get closer and closer to 3? What number is that?
4.
4.
Yes.
4 is the answer. 4 is the limit.
Yes.
What that means is as you come from the left side and the right side, where's the graph approaching? That's a limit, right? It's like a speed limit on the highway, right? Speed limit. You could be a little bit above it, a little bit below it,
That's just saying that we
and you are approximately as close as you can be, and that's a speed limit, right? That's why there's a little bit of give and take to the law on speed. You can be a few miles over, a few miles under, and you're still fine. Not a super crazy amount. You're within a certain frame of whatever the officer chooses.
My dad always says you can go 9 over, but once you go 10 over, you're in trouble.
Word.
First thing around here, I would not go above 5. I just wouldn't, just around
Corey
guard.
Graham said,
Dude,
just
I
one
would
fine,
be
5 your mind.
The speed limit.
He says 5, you're what?
Speed limits
4
are
your fine, 5 your
recommendations,
mind.
Yeah, so that's usually the thing around Garner. It's about 5 miles per hour. That's the
Not the new guy.
Or he's
Rusty Schmidt.
Word.
Now,
Word.
Rusty Schmidt has also been known to say, though, I am the law.
Where is
oh,
the
did he
picture?
check in? I better put my headphones
Where
on.
is the picture of the graph at?
Scroll way down. Scroll. You'll see it right. Keep going. You'll see it. Oh, I think you just passed it. It's right around my son's face. He's wearing a red T-shirt. That's how I always look at it. Oh, this is further. You're right. He's wearing a red T-shirt. You'll see him. There it is. And you can make it bigger by dragging the corner.
That's probably the
All right.
last job I
Sorry, Ryan. I didn't realize you checked in. But you didn't.
Probably.
All right.
Oops.
Okay. All right. Now, hey.
He made a noise. It went. Doop, doop.
Oh, I didn't hear it. I can't do that. All right. Now, the limit. Now, notice the limit of this thing as you approach from the right and left side. You're approaching what this y value was right there. There was an open hole there. The answer is still 4. That's the limit. You're approaching 4 on the graph. It may not be the exact answer of the function, but it was the limit as we got closer from both sides. As what they say, you approach from the right and the left side of it. Now, the functional value is different. If I were to actually take the number 3 and plug it into my graph, it's the dot at the top of the graph. So when you actually evaluate the function and plug in 3, that could be a completely different number than your function, right? That could be different than the limit. The limit, the graph is telling me it's approaching 4, but when I actually plugged it into the formula, the answer that it spit out was 8. You see the differences there. The limit, you follow the graph lines. The functional value, you look for where the solid dot is sitting, and that's the answer. The dot could be at a different spot than where the graph is pointing me towards. because of like the open holes.
So
and
say for example, if I said limit fx equals 2
okay, so as we approach 2.
as we approach 2.
Okay, so if we
So that
approach
would be-
2, so as we approach
Where do you
2,
start from?
Zero.
okay,
So then it would be 5.
so as I approach 2, I'm getting closer and closer. The limit would be 5, roughly. It's close.
What if there's not a line there?
Okay, so if there's no line, let's say we're approaching, $7 point, what is this?
7.5.
This is 9.5 here,
Yeah.
negative 9.5. There's no limit. There's no limit because there's no
The
graph.
limit does not exist.
The limit does not exist.
Just like speed limits.
Okay.
Exactly.
Does anyone know where that's from?
I was gonna say that, but I think I'm.
I was like, does no one know?
Mean Girls.
Mean Girls.
So,
I
okay,
was
so
like, that's
this,
embarrassing if
in
I
this
just
case,
said
the limit
that.
doesn't exist because the graph wouldn't go there. Now, if your graph goes two different directions,
This was what.
like right here, if we approach the right and left side of 0, let's say we're gonna do 0 here,
You pick the top one.
okay? You approach the right and left side, right? So I'm approaching from this side on the graph, getting closer and closer to 0, approaching from the right. Are they approaching the same number?
Yes.
No, one's approaching the top. This right side is approaching the top. What is that, 5 or 6? What is that, 6? And then this number's approaching 2. Since they're approaching different numbers, your limit does not exist.
Wait, why is the right one going?
The graph,
Why is it approaching the dark circle with the arrows pointing down? What?
this, as they approach the left, you have to follow the curve.
No, the other one.
This one's going up.
But
Right.
the arrow's pointing down.
Yeah, it's just pointing there.
No, the other side.
That?
Yeah, why is it?
Oh, that's just, as I went this direction, that arrow's just gonna
So
continue.
it can't overlap
I
each other?
think it goes like that.
Yeah, you're fine. All right.
So it has to be 1 point or it doesn't exist.
Yeah, it has to go to 1 point or the limit doesn't exist. So now, even if there's a hole in the graph, you would tell me where it's going, as long as it's both the right and left side are approaching that number, like I was saying earlier. Okay, what was the question? I saw somebody's hand. What was it?
Well, I did, but I don't know.
That's all there
I
is
was,
to
I was,
it.
I was just asking, like thinking, why does that dot that's floating up there, how come that one works, but then the one that
Okay,
says
so
0,
because a limit, when you look at a limit, whatever number you're looking at, they as you go from the right and left side, they have to be, the graph has to be going towards the same dot. So my graph was looking like it was going to hit, what was that, 4?
Yeah.
That's why that was a limit. That was the limit at that location. My graph is pointing towards that. But when I did 0 here, and I went from the right and left side, they were pointing at completely two different numbers. This one's pointing at 2, that one's pointing at 6.
So that's not existing.
That's why it doesn't exist. Now, don't get me wrong. If I wanted you to evaluate the function at 0,
That's top.
then you have to pick the dot that's solid.
What if there's no dot?
Hold on, re-explain what you just said, because he figured something out and I didn't. I got it.
If I wanted to evaluate the function, like actually plug a 0 into the function, so I plugged 0 in, evaluate, not a limit, just to actually evaluate, you have to pick the solid dot. The solid is the answer at 0.
If there's not one, then it'd be.
Nothing, it wouldn't exist, right? There wouldn't be an answer.
Open dot is the
What
one.
if-
I got it. Plausible answer.
Question.
I don't.
So what if you see the one on the left, like the
Right,
red
somebody's
line's one
got
on the
it.
left and one on the right? What if your X,
I need a math
the arrow thing is in between those two?
Okay, so if your limit was in between like negative 9.5, you wouldn't have a limit. You wouldn't even have a
Does not
functional
exist.
value because there's nothing there. It's just an open gap.
So you put does not exist?
Yeah, it does not exist.
So with these, are we just gonna have to read them?
Yeah, so what you're gonna do, you're gonna be given a graph, like a picture, and you're gonna have to tell me where is my graph going on this picture.
So if it said as X approaches like 0, do we go on 5 or
Can't get it.
So if you're saying as you're going from left and right from 0,
Well, like instead of being cool, we're just like.
Never mind. I can do it.
Just roll it down.
you get it? No.
No.
Oh, okay.
I don't get this.
I love it.
All right. So let's do another one. Maybe I'll draw a new picture.
Yes, please.
All right.
Make a like smiley face. Yes.
What?
God, Trav, what are you doing?
Oh yes.
Are we ever gonna get one like this?
Yes.
Now make the other eye like really big.
Put the other eye way at the top.
Put another eye up there.
No.
Why not?
They just make it a slant eye.
I demand it.
Oh my
Yeah.
gosh.
This is great.
All right. Hold on.
He's silly.
He's silly.
All right.
Silly. Hey, why?
Okay.
He's missing a tooth like me.
So, okay. First,
Inclusive.
okay, we have a bunch of gaps in this drawing. What we're going to do is we're going to look at limits only first, and then we'll look at functional values second. So limits are you follow the curve and point where it's going. So if I want to go the limit as x approaches -2. Okay, so find -2 on the x-axis.
Right there.
-2 is here, right?
Yeah.
Go down and tell me what number was I roughly going to hit as I went from left and right side.
4.5.
Do we
Negative-
look on the y-axis?
Negative 4.5.
Yeah, you tell me the y-axis number.
0.5.
-4.5.
Yeah.
That's where the graph is approaching, right and left side, right?
Yep.
If I picked, let's say I want to approach -1 from the right and left side,
Non-existent.
No, it's 5.
you would look at, okay, as I come from the right and the left, where am I roughly going towards?
Hi.
-5. That's your answer.
It's an open circle.
It's an open circle, but do you agree, as I went from the left side to the right side of the curve, they were going towards -5?
Yeah.
That's a limit. You're just telling me roughly where are they going towards?
It's only when you plug it in.
Okay, yeah. There, even though if you, like Jake even said, like, hey, there's a dot above this though. There's a dot up there. That's different. That's a functional
That's
answer.
asking for the real.
That's the answer if I were to substitute in -1.
Wait, are there
I'm just looking
any-
where is the graph going.
Wait, so is there always a dot where an open circle is
Usually,
on
yes.
a different?
Yes. There's usually a dot somewhere else. And you don't have to look at the
And
dot.
that's if.
That's, yeah, that's, you use the dot when they ask a question like this. Find f at -1. That means you're not looking at the graph, you're
So it
just
doesn't
finding the
say limit.
dot.
So it doesn't say limit on the question.
It didn't say the
So
limit.
that wouldn't be positive, like,
Whatever.
let's say.
7.
7, 8, something.
Yeah, 7 or 8.
That's
'Cause you,
what I was confused.
yeah, this is asking for where's the dot solid at. That's asking where is the graph going towards. But they have to be
Your
approaching the
iPad
same
is
number.
broken. Oh, I got it.
Okay.
So if x was approaching 3,
Okay.
that'd be
Okay.
like negative.
All right, so
6 or
so here we go. This is the question I want to get to. This is like one of the last things today. I want to approach 3. Okay, so as I'm approaching 3 on this graph, and again, we're looking at the graph now, not the solid dots or anything. We're looking at the graph because it's the limit, right? I'm approaching 3. Here's 3. As I'm approaching, are they approaching the same number?
No.
No, the limit would not exist because there's a gap. There's too big of a gap. It's not like both sides are infinitely close to that thing. There was a huge gap on the right side. It's too big. It's not just right there. There's not just an open circle. There was a huge gap, so that wouldn't have a limit.
So it has to have 2 lines on each side of the point.
Exactly.
To be able to.
Yes. Yes. So, hey,
Does not exist.
so Jared just said, he said the most important thing, for a limit to exist,
This hole.
They have to connect.
they have to connect at a circle.
Oh,
Either a solid or an open circle.
Wait.
If there's a gap anywhere around it, it wouldn't exist.
And then the points don't matter if there's a.
It doesn't matter about a limit. We follow the
So
graph.
if it said, what's the limit as x
That's what
approaches
I'm
3.5? Would it be no limit?
Yeah, because there's no open circle.
But if there's an open circle, it's,
You sure?
what is it?
It would be, that's the limit wherever that thing would be.
You said it's-
If there was an open circle and you're going towards it, that would be the limit.
I'll never tell you.
Or are you talking about the
No,
dot?
like, let's say for that graph.
Yeah.
You tell the joke.
Wait, so
Yes.
Say it again?
Yeah.
You
said that there's not a limit.
3.
Okay,
Said that
so
there wasn't a
if this is an
limit.
open circle and you're doing the limit,
It stopped.
as you went from the left to right, there's no limit there.
Because it's not
So
connected,
no
right?
limit.
No
So
limit.
it'd be the same thing if there wasn't even a line there that says what's, as x approaches 3.5. There's no line whatsoever or circle.
So that doesn't exist either.
So
limit does
it'd
not
be the
exist.
same answer?
Yeah.
Come on,
So say I were to
I
say
didn't know
like,
there
what
was
is that
different
over there, negative 10 or whatever?
Yes.
You're like, as x approaches
Oh,
negative 10, what's the limit?
It's gonna be up here somewhere. You'll have to figure out where it's gonna go through.
Wait, how do we know that?
Why?
Because this graph continues
Oh, shoot.
Is
And
it
you have to kind of
slope
figure out, as I go closer and closer to negative 10, where would that graph actually
That makes
hit?
sense.
So is there gonna be a slope that we have to follow?
Yeah, they would give you something easy. They'd be like, in that situation, it'd probably be like a straight line. So you can kind of follow where they're
I
going.
don't wanna do that. Are we gonna
Okay.
have to do that?
Eventually.
So,
Question.
So when it's at 3, you're doing the limit to 3. It's non-existent because it's not connected.
Yeah, it's not connected on both sides of it.
Okay.
Now, the functional value there, if I said
That
find
would be the
f of
bottom.
3,
That would be
that would be the bottom number.
Because
It's just a dot.
But if it
I
was
got it
negative,
now,
if it was 2, it'd work, right?
Yes.
It'd be a.
alright, perfect. I understand it.
But what if it's
Don't add
4?
anything more. Let's pack it.
4,
Because it's still.
non-existent.
non-existent. Now,
would.
Wait.
I'm going to wait to throw a little kink in the plan until tomorrow. I think we're going to stop here.
Wait,
I
so
better
if
stop.
it's
I knew it.
asking for the limit, it'd be non-existent because it's not a limit.
That's how.
Okay, I'm waiting until tomorrow, because right now you guys seem like you have a really good handle, and I don't want to break that right now.
Did that something to do with the open circle and the closed circle?
Yeah, but
Alright,
Brian, I'll talk to you. I'll talk to you later. I need to send you an email with the worksheet that you have because I forgot to send that to you yesterday. So, okay,
I'm not gonna lie, once I get back, I'm gonna need a lot of extra help.
that's
I'm really
fine.
lost.
I'll be here.
Test Tuesday.
So, okay,
Is that everything for today?
yep, that's it.
Alright,
Okay,
yeah.
see you later, bud.
Got a whole board. Start golf. You gotta ask for. You gotta ask for help.
Nope, you got it. Homework, go.
Tires are for the boy.
All right, did you take screenshots? No.
I'm gonna. Great, new manage to it. Mr. Warren's gotta help you. Do we need to pull out the picture or something?
It's already an hour.
Your package.
Well, that's right.
Me too.
All right.
So it's at 1-4.
Oh.
This one
Go.
is.
Go do it.
I'm too far away. Man, now you gotta board.
Hey, good luck to volleyball tonight. Good luck to cross country today. Good luck. Lots of stuff going on. Who is your guys' manager?
What?
Who's the manager that's getting the camera today? Because you guys leave at like 3:30.
Daddy. I don't know.
So I need to have the camera like ready to go.
Give it to Chloe. Give it to Chloe when she leaves.
Oh yeah.